Welcome to this episode of the Industrial Engineering Notebook. Today's topic is the minimum spanning tree. This algorithm is a really good introduction to networks, nodes, edges, all of that stuff. It's a good introduction to algorithms in general, so let's get started. So these are called nodes. Let's kind of just imagine that these are like production cells at your widget factory, and we can connect them with lines like this, which are called edges. And in this example, let's just pretend that maybe these are some possible pathways between the cells that you could build in your factory. And again, these are called edges. So possible pathways here, right? And you're not sure which one you want to build, right? You could build a number of these, but really what you want to do is you want to minimize costs. You only want to build what you absolutely have to. That way you can save your factory some money. Let's say you run the numbers and you come up with a cost for building each of these possible pathways. So those are our costs. We'll just say they're costs in dollars, maybe not $4, maybe like 4,000, right? Put some stakes up. But you're probably looking at this and you're thinking, listen, guy, I could build, I pretty much can just figure out which pathways I should build looking at these numbers. This is not a hard example. And you'd be right. This isn't a hard example. You probably could figure it out if you wanted. But the point of explaining minimum spanning tree to you is not solving this diagram. It's for when you get a situation that is way more complicated than this and you can't sit down and analyze the possibility of every single pathway. So we're just going to use this example to understand the minimum spanning tree algorithm. We'll see how it works. We'll see how we don't really have to think about it as we're doing it. And then hopefully you'll be able to apply this to more complicated situations moving forward. By the way, this whole thing is called a network. This system of nodes and edges is called a network. So we have some goals here. Number one, and this is pretty self-explanatory, we got to minimize that cost. Number two, no cycles. What is a cycle? It's not that thing that you ride around town. A cycle is if you have, let's say you built this pathway, and then you built this pathway, and then you built this pathway. That would be a cycle, because if you start at D, and then you go to B and A, you can get back to D. And we don't want that because A was already connected to D through B. So no cycles like this. And this isn't really a goal, but this is just important information to remember. We're going to break ties arbitrarily. I hope that's spelled right. We're going to break ties arbitrarily. So if it's, if we're deciding between 3 here and 3 there, we're going to break that tie arbitrarily. Doesn't matter which one we pick, just pick one. All right, first step in the algorithm. Pick any starting node and connect at lowest cost. Okay, pretty simple. Step 2, update K and U. What are these? Good question. Thank you for asking. K is going to be the set of connected nodes, and U is going to be the set of unconnected nodes. So that's what they look like starting out. Beginning, K is, this little symbol means empty set. So there's nothing in the connected nodes. We haven't connected any nodes. You're like, well, there are connections here. Well, we haven't built. These are just possible pathways right now. We haven't built any connections yet. And then all of our nodes right now are in the unconnected set. Why did I pick K for connected? So we don't have 2 C's going on there. So K stands for connected. I don't care about spelling. And 3 is pretty similar to 1. It's just connecting an element in U that is closest to an element in K. So you look at all of the elements in U and then all of the elements in K, and you just the shortest or the least expensive path. And here's our stop condition. We're just going to repeat 2 and 3 until U is an empty set. All right, right off the bat, number 1, we got to pick any starting node and connect it at lowest cost. I mean, D seems like a pretty good starting node, and the lowest cost, we got 2, 4, 1, 8, 4, 7. So definitely the 1 is the lowest. So we update the set of connected nodes and we update the set of unconnected nodes. 1 iteration done. Next. All right, lowest connection to C and D. You've got a 2, a 4, a 3, a 6, a 8, a 4, a 7. Definitely 2. Next iteration, we got a 4, a 3, a 6, a 8, a 4, a 7. 3 it is. We update our sets and then we come back here. We're not worried about this connection anymore because B is already connected. That obviously doesn't matter because B and A are already in our connected set. So we start looking over here. We got a 6, an 8, a 4, and a 7. So 4. Update our sets. And then looking at our next connection. So we could do a 3 there, an 8, a 6, 7, 5. This one doesn't matter because it's just connecting 2 unconnected nodes. So looks like we have to choose between either this 3 or this 3. And remember that we break ties arbitrarily. So I'm going to go up there to E. G and H are left. So we got a 5 here and a 3 there. We also could go here for a 7. 3 wins. And the last node, we're gonna make this one connection here. And then after updating K and U, we notice that U now equals an empty set, and we are done. So this is our minimum spanning tree. Just by following these steps, we were able to minimize cost, and there are no cycles in here. So the algorithm worked it out, so we have no cycles. It knew that it saw this connection between D and E of, cost of 8, and it knew to take 4 and 3 to get there, cost of 7 to connect E as opposed to going for this cost of 8. I guess it also could have done that, so maybe if we had chosen differently, it would have done that. Who knows? The point is, all you need to do is follow these steps, and it will give you the answer that you're looking for. So when you have more complicated networks, you can just either write some code that will do these steps for you, or whatever, and you will be able to minimize some costs on your factory floor. If you found this helpful, hit the like button. If you want to see more, hit the subscribe button. If you have questions, put it in the comments. And I am not going to put that O there.